A capacitance hat, often called a capacity hat or cap hat, is a conductive structure, usually a set of radial spokes, a wire loop, or a metal disc attached to an antenna, typically at the very top of a vertical or at the ends of a dipole. Its primary purpose is to electrically lengthen an antenna that is physically shorter than its natural resonant length. Here is a breakdown of how it works and why it is used in antenna design. When an antenna like a quarter wave vertical or a half wave dipole is cut shorter than its resonant length, its impedance changes. The radiation resistance drops and the antenna becomes highly capacitive. To make the transmitter happy and get the antenna to resonate, you have to cancel out that capacitance, usually by adding a loading coil and inductor at the base or middle of the antenna. However, simply adding a large loading coil reduces the antenna's efficiency and drastically narrows its bandwidth. In a full-sized antenna, the RF current is highest at the feed point and tapers off to zero at the very tips of the wire or tubing. When you physically chop off the ends to make the antenna shorter, you are removing the section where the current would normally taper off. By placing a capacitance hat at the ends of the antenna, you give the RF current a place to flow and accumulate. This does a few critical things. Pulls the current up. It draws the current distribution further along the radiating element instead of letting it bottleneck at a loading coil. This maximizes the current on the main vertical or horizontal wire, which is what actually radiates your signal. Reduces coil losses. Because the hat adds capacitance to the end of the antenna, you don't need as large of a loading coil to achieve resonance. Smaller coils means less resistive loss. Widens bandwidth. Antennas shortened with capacity hats typically have a wider usable bandwidth, lower SWR across a broader range of frequencies, than those shortened purely with inductors. Capacitance hats are highly valuable for low frequency operations on bands like 80 meter or 160 meter, where a full-sized antenna is often prohibitively large. If you are making a physically restricted antenna resonate on 160 meter without increasing the total length of the wire or moving the feed point, adding capacity hats to the ends, often in conjunction with carefully calculated loading coils further down the wire, is one of the most efficient ways to achieve it.